Okay, we're in section 28 of the notes, and the big issue here is the rectangular coordinate system, which I believe that most students are already familiar with from prior learning. This is placing a point in a plane. And then we talked about, things about certainly we talked about points. We talked about midpoint between 2 points, and we also talked about the distance between 2 points. Hopefully, you paid attention during the lecture and you have a fairly good appreciation on how to compute distance, a fairly good appreciation how to complete midpoint. I do want to emphasize, though, if you have trouble with this, please spend time studying this material. All right. The goal, though, is this. We need to be able to do these problems that presented over here. I want to go through that with you. All right. So we're going to switch to the whiteboard. And as I do that, I got to get to the whiteboard, right? Give me a moment to do so. And as I do these things over here, again, you may decide that you're going to do it a little bit differently, but the outcomes can't be different. It can't be a different outcome in these problems over here. So one step at a time. Whoops, I think I made a mistake there. Give me 1 second, okay? Okay, so the deal over here is that, we'll do one example at a time. As I do these problems over here, my emphasis is on doing the problem now. All right, so as I'm reading these things over here, I want to point out, they give me 2 ordered pairs, and they give me graph paper 2, which I'll talk about later. But right now, they want the distance between those 2 points. Let me give you the distance formula from the get-go, okay? So I'll write this over here. So the distance formula between 2 points, and yes, you need to know this. I'll call this P1. It's going to be X sub 1, Y sub 1. That's P1. P2 is going to be X2, comma Y2. All right. The distance formula. There's many ways to write this down, but I'll write down, a formula that you should be familiar with at this point. Change in X squared plus the change in Y squared. In the Y squared, sorry. So then someone goes, what are the points? Well, let's write this down. So P1 is the point -5, 0, and P2 is the point 0, comma -3. All right, I'm going to go through the work, and I want to talk about what these things mean to me. This is X1. This is Y1. This is X2. This is Y2. What's the distance? Let me point this out to you. X2, which is 0, minus, let's write this down, X1. X1 is -5. So what do you get? 0 minus a -5. What's that going to be? 0 plus 5. Let's do the next one. And mistakes can happen. Y2. What's Y2? It's -3. Let me write that down. Minus, let's see. Whoops, I made a mistake in the formula. I just saw it too. Let me erase that. I'm sorry about that. That wouldn't make any sense. Sorry about that. So what do? It's going to be Y2 minus Y1. Well, what's Y1? It's 0. Let's put that in there. Yes, you're expected to do the arithmetic. Let's write this down. D equals, let's see, 0 plus 5 is 5. 5 squared is 25. Plus -3 minus 0 is -3. And -3 squared is 9. So this will be root 34. All right. I want to go back and I want to read the question, see if I've done what they said to do. All right. They said graph it. We haven't done that yet. We'll get there later. Determine the distance between the points. Did I do that? Yep. And the midpoint. I didn't do the midpoint yet. Let's do midpoint. And what's midpoint going to be? I'll write this over here as midpoint. Midpoint's a point, and the point's going to be the average. So it's going to be x1 plus x2. I just add two things together. I'm adding the points together. Divide by 2, comma, y1 plus y2, divide by 2. All right, this is the distance. We got the distance done. And let's see if we get the midpoint done. So what do you get over here? Someone says, what's x1? Well, I'm reading it. I'll write down for you. It's -5 plus what's x2? It's 0 over 2, comma. What's y1? Oh, geez, 0. What's y2? It's -3. So I'll put the midpoint down. What do you get over there? -5 over 2, comma, -3 over 2. All right. So I got the distance, and this is the midpoint. All right. We'll look at our key later. I want to keep reading it, though. We didn't do the graphing yet. So it says, graph the other, I haven't done that yet. Determine the distance. I've done that. And I've done the midpoint. Okay. So graph the ordered pair. I haven't done that yet. Determine the distance between these 2 points. I've done that. And the midpoint. I've done that. Let's see if we've done it right, though. So I'm going to point over here. Did I get the square root of 34 for the distance? Yes. Did I get the midpoint -5/2 -3/2? Yes. I feel pretty good about that. Now, someone says, why did they do this over here? It's a good idea to approximate it. In WebAssign, they'll ask you to approximate, sometimes, not all the time. So how do you do that? You need to take your calculator and you need to take the square root of 34. I think you'll be able to do that. If, for whatever reason, you do not know how to use a calculator by this point, come by during office hours and we can discuss that and we can get you proficient with using a calculator, at least as far as taking a square root is concerned. All right. And we'll help you with that. All right. Now, I didn't do the graphing part. So someone says, are you going to do the graphing part? Of course I am. They asked me to do it. So what I want to do is I want to look at this graph, right? And I want to plot the point -5, 0. What that means. This is the origin, -1, -2, -3, -4, -5. I need to plot that point, by the way. I'll write that down for you. That's the point, -5, 0. Yes, we need practice. All right. What's the other point? Well, the other point, I'm going to zoom back, is 0 -3. All right, 0 -3. Now, I hope you realize the ordered pairs. I'll put this over here, 0 -3. The ordered pairs are always given in the same order. The order is going to be x, which is the abscissa, and y, which is the ordinate. Let me point out what I mean by that. This is the x-axis, or the abscissa. This is the y-axis, or the ordinate. The origin is 0. This is even labeled that way. So what does it mean? Along the x-axis, like 1, 2, 3, 4. If you go in this direction, -1, -2, -3, -4, -5. Now you notice a 0 there. It means don't go up or down. How about this one? What would that be? Well, along the x-axis, you do not move. You stay at the origin. But along the y, you go down 3 units. I'll put that down for you. Oops, I'll put it in red. Sorry about that. Okay, here comes the part where I actually believe you have a good graph. You'll be able to draw a line through those. And I'm not really good at drawing lines, but something like this over here. My gut feeling is this. You probably could draw a triangle now. Now, someone says, why would you draw a triangle? Well, the triangle I'm drawing is a right triangle, which is the Pythagorean theorem now. And I'm looking at this thing. It's fairly simple to do. I'm not going to say you want to do it this way, but this would be the number 3 here. That is a length of 3, and this is a length of 5. And my question is, what's this over here? Well, Pythagorean theorem is a squared plus b squared, and the hypotenuse is called c in Pythagorean theorem, so c squared. So what's a squared? Well, looking at it, I'm going to say a is 5, and this would be b. So it's going to be 25 plus 9 equals c squared. And what do you get over there? Well, looking at it, that's 34, isn't it? So what's c? We're using the square root rule. You might say plus or minus, but distance is a positive number. So root 34. So what's the distance? I'm using the letter D now, is root 34. just like we had before. Now, what's the midpoint? I'm kind of looking at it. I know it's difficult. I'd hate to think you're going to do it this way, but the midpoint's over here. And what is that point? Looking at it, it looks like minus 5/2. It's the dead center over here, which is right here. And then the dead center over here, which is minus 3/2. All right, same result we're getting before. All right, so we did the graph. All right, let me point out what I'm talking about. We did everything. We did the distance, we did the midpoint, and we graphed it, where the two above concepts can be visualized. You may decide, though, that the graph paper I'm providing you is not the graph paper you want to use. Go to the internet, type in graph paper, and a ton of different examples of graph paper will come up. If you're using my notes, though, you can blow this graph paper up, and it's not a bad idea to do that. All right, let me do the next problem, and I want to read it to you. It says over here, find the distance near 100. Nothing about graphing, which I'm glad. I don't like graphing anyway. So it says find, it looks pretty simple. So I think I'm getting ready for this. All right, so distance, I'm going to label this for you. And this is going to be x1. This is going to be y1. No, you don't need to do this. I just want to make sure for students that want to do that, they can. This will be x2. And this will be y2. Now, I think midpoint's the easiest one to do first. And what's midpoint going to be? X1 plus x2 over 2, comma, y1 plus y2 over 2. Let's do the midpoint first. What's x1? 4. What's x2? 6. And I'll do that arithmetic later. What's y1? 5. What's y2? 3. We'll divide by 2. We'll check with the key 2. So what do you get? 4 plus 6 is 10. 10 divided by 2 is 5. 5 plus 3 is 8. 8 divided by 2 is 4. So I'm going to claim that's a midpoint, and we agree with them, and that's good news. Let's put the distance formula down now. What's going to be? Distance, yes, you need to know the formula. What's that going to be? x2 minus x1 squared plus y2 minus y1 squared. Let's go to work. Again, if you can't, remember things, that's why we write things down for you. All right, it's easy to forget, especially things that you're not interested in. So what's x2? It's 6. All right, what's x1? Is 4. We'll do that later. What's y2? Is 3. People make mistakes, myself included, by the way. Minus y1, which is 5. Let's keep going. And what do you get there? The root gets smaller. 6 minus 4 is 2, and 2 squared is 4. 3 minus 5 is minus 2, and minus 2 squared is 4. 4 plus 4 is 8. If I were to put this in simplest radical forms, though, that would be, well, 8's got a 4 in it, so it's 2 root 2. So that's the distance. However, they're asking you to approximate it. My suggestion is to use a calculator to do so. So in a calculator, if you do the square root of 8, or if you did 2 times the square root of 2, you would get approximately 2.83. Again, repeat this, for students struggling with the use of a calculator, come by during office hours, and we will be more than, when I say we, the tutors, everyone at Essex is there to help you learn the material. And I really do mean that. And I would feel bad if someone wasn't there to help you. We're there to help you. All right, you got to help yourself first, though. Let's see if we got that right. I'm seeing the square root of 8, and I'm seeing the 2.83. All right, they say you can also visualize it. Yes, you can visualize it if you want. All right, now if they give you graph paper, I want to point out, use the graph paper. So I'm going to go back over here. I'm going to reuse this graph paper to visualize it. All right, let me get my eraser out. I think I can erase this, right? I'm going to use it. And someone says, why do you want to use that? I just want to see if I can do it. Let me get my eraser out too. Whoops, sorry, that's not my eraser. By the way, do not feel obligated to do this. You've already answered the question. What I want to do is I want to blow this thing up here. And I want to plot those points. So someone says, where's 4, 5? This point here, P1. You would go over 1, 2, 3, 4, and then up 5. Okay, you get the idea? Let me do that with a red pen. So I'm going to go over 4 and then up 5. All right, let me point out what I just did. 1, 2, 3, 4, and I'm up 5. 1, 2, 3, 4, 5. That's done. That's P1. Let's do P2. P2, I have to go over 6 and then up 3. Let me do that. I'm going to point out what I did there. 1, 2, 3, 4, 5, 6, up 3. 1, 2, 3. Not so bad, right? Let me draw my line segment between those two. By the way, I think, looking at this thing, that you could get the midpoint here. All right, I'm going to put that, we'll check with the key later. All right, well, you can blow it up, but I'm looking at it. Let's just count over. Again, I'm not recommending you have to do this. I'm looking at this point over here. 1, 2, 3, 4, 5. That's X 5. 1, 2, 3, 4. I'm going to say 5, 4. Oops, go back to my ink color. Let's go back to our key. Boy, same answer we got over here. Now let's do our distance thing. Now, I want to point out, if you're doing distance, what you're basically doing is you're drawing a triangle in, something like this over here. And I'm going to say, just looking at it with my graph paper that I'm using, I'm going to call this A is 2, and this is B. I'm seeing 2 units there, and B is 2, and this is going to be C. What do I get? A squared plus B squared. It's a right triangle, by the way. The side opposite the right angle is called the hypotenuse. That's C squared. So what's A squared? 4. What's B squared? 4. That equals C squared, which is the distance. 4 plus 4 is 8. Remember, distance is a positive, so it's not plus or minus. C is the root of 8. So what's the distance? It's the square root of 8. Or it's 2 root 2. Or if you want to approximate, you can do that too. All right. So I want to make sure you know that that's been done. They didn't ask me to graph it though, but you may decide, hey, I want to graph it. I want to see how these things look. You'll learn by doing that, by the way. All right. And again, I know this is difficult with the graphing, but we're going to do more and more graphing as time goes on. Let's go to the next page. And yeah, they gave me graph paper there. Let me look at number 3. Number 3 looks a little strange to me. They say graph the ordered pair solutions of this. And I'm looking at it, and it doesn't look easy. So I'm gonna pull this part to the side. And I'll use the graph paper later. All right, so I'm gonna see if I can figure it out. And they say X is, let me write this down for you. X is minus 3, and Y is, well, what is Y? It's this thing over here. Well, I got to plug that in. What do I get? Minus, whoops, sorry about that. Minus, parenthesize the variable, and we'll plug it in. What's X? It's minus 3. What do you get there? Y equals minus, what's minus 3 squared? 9. And what's minus 9 plus 5? Minus 4. So I have my first ordered pair. What is it? Minus 3, comma, minus 4. Let's do the other ordered pair. What is it going to be? X equals 1. What's Y? Y is equal to minus something squared plus 5. What's X? It's 1. So what do you get? Y equals minus 1 plus 5, which is 4. Let's write that down. 1, 4. All right. What I want to do is I want to plot those 2 points. All right. So we want to plot them on the graph paper. All right. So I want to plot the point Let's see, I'll write them over here. I don't want to lose track of that. -3, -4, and I want to plot the 0.14. Again, if you look back in the original problem, they asked me to do this. All right, so see if we can do that. And I gotta do it. I'm getting better though. -3, -4. One, 4. I'm gonna blow this up. And I want to make sure you know what I'm looking at. This is the point 1, comma 4. This is the point -3, comma -4. All right. Now, what do they want me to do? Well, let me point out what they want me to do. They want me to graph it. I just did it. I graphed the ordered pair of solutions. Now, again, I might have them wrong. Who knows? I make mistakes in articulate, right? Now they say find the distance. Well, I got a distance formula, and I'll write this down for you. I'm getting a little better at it. And I'm going to put this over here. I'm going to put the distance down, right? What's distance? I'm getting a little better right now. I'm going to say change in x's. So 1 minus a -3 squared plus 4 minus a -4, which is +4 squared, d equals, let's see, 1 plus 3 is 4, 4 squared is 16, 4 plus 4 is 8, 8 squared is 64, right? D equals, well, 16 plus 64 is 80. That's not so bad. Again, if I were doing this thing, and not that you want to do it, but I'd probably say this is probably can be simplified. 16 times 5, right? 16 times 5, what is that going to be? It's 50 and 30 is 80, right? What's square root of 16 is 4. So what is it? It's 4 root 5s. All right, that's what it is. I want to go back to my picture though. And I want to see if that really corresponds to this thing over here. Now, I hope I'm not making you dizzy with this. So what I want to do is, and again, I know it's difficult, but I'm kind of drawing a line through that. And if I have a, whoops, I didn't do a very good job, didn't I? So I'm going to draw a triangle. I know it's tough. I'm going to call this thing A. I'm going to call this thing B. And I guess we should be trying to learn, right? What's A? I'll count it. And someone says, what do you mean you're counting? The blocks, 1, 2, 3, 4. Looks like A is 4. Let's do B. It's a counting problem, right? 1, 2, 3, 4, 5, 6, 7, 8. I'll write that down for you. This is C, the hypotenuse. It's the side opposite the right triangle, the right angle, I mean. So what do you have here? A squared plus B squared equals C squared. What's A squared? 16. What's B squared? 64. That's C squared. 16 plus 64 is 80. Remember, distances are positive. So what's C? It's the square root of 80, not plus or minus, by the way, which means the distance is root 80. I think we just did that, right? And that's going to be 16 times 5, where distance would equal 4 root 5s. All right, we'll look at the key later. Let me go back to this. I know I'm blowing things up a lot on you, but it says, find it. Oh, they want me to round it off. So you need to use your calculator. So I want to point out, if you look at this thing over here, I do see root 80. You need to use a calculator to do that. Again, I repeat this. If you have a trouble doing this by calculator, come by during office hours and we can discuss it. I can discuss web-based applications that allow you to calculate this. And also if you have a 4-function calculator, you probably have to turn your calculator on, and I could probably try to teach you how to use your calculator by Zoom, all right? Okay, they also say the midpoint. So I'm gonna go over here, and I really think, the midpoint should be really easy for me to do, and I'll put the midpoint down over here. Well, let me back in blue. What do I do? Add the points together. So -3 plus 1 is -2. Divide by 2. -4 plus 4 is 0. Divide by 2. And what would you get over there? -1, comma 0. So that's a midpoint. I also want to look at my picture. And I got to be honest with you. Sometimes my pictures are just awful. But if I have good graph paper, probably it's going to be a little bit better. So I'm looking at this thing and I'm saying, this here looks like the midpoint between those 2 points. Who knows? I might be wrong though. What is that point? Well, I'm going to say looking at that point there, the midpoint looking at by inspection looks like -1, All right. Are we in agreement though? Let's take a look at the key. Bingo. Both our formula and looking at the picture leads to the same answer, which is good news. All right. That was number 3. And let's see if there's a number 4. Oh, this one I don't want to visualize. They're nasty looking numbers. All right. And you're allowed to use calculators. I have no objection to using one. Let's label these things. X1, Y1, X2, Y2. Oh, let's write distance down. They want the distance and the midpoint. I think I want to do midpoint first. I think it's easier. Let me repeat this. You're allowed to use calculators if you can't do the arithmetic. So I'm going to add the x's together. That's 5.3. And then plus minus 2.7 is like minus 2.7. We'll do that later. Now it's going to be minus 6.4 plus 3.1. All right, repeat this. If you have a tough time with computing, like doing arithmetic, use the calculator. No one's going to know anyway. What do you get over here? 5.3 minus 2.7. Well, let's see. That's going to give me, let's see. I got a 2 on the bottom for sure. That's not a problem. 5.3 minus 2.7, 1.3, 1.6. I'll do that later. Comma. This is 2. This will give me minus 3.3. All right. I think I can divide 1.6 by 2. Right? I'm sorry. That's 2.6. I'm sorry. Made a mistake there. 5.3 minus 2.7 is 2.6. I apologize. 2.6 divided by 2 is 1.3. Look at the key later. Minus 3.3, that would be minus 1.5 and another 0.15, 0.165. Let's take a look. I say that's a midpoint. They agree with it. Let's do the distance now. And that can be a little bit more difficult. And I know that. Right? Midpoints are generally very easy to do. You know what I want to do? I want to erase a little bit of work over here because it doesn't look right. I just traced over that. That's 2.6, and I apologize. Whoops, 2.6. All right, let's do the distance now. And it's nasty, there's no doubt about it. So minus 2.7 minus 5.3 squared plus, and yes, I'm going to do the arithmetic. You're free to use a calculator. Minus 2.7 plus 6.4. All right, push this over. And, you know, one step at a time. I really mean it too. Let's see, minus 2.7 minus 5.3. That's going to be minus 8. And I'll go slow. That's not so bad. Plus, let's see, 3.7. Let me check that. 3.7 plus 2.75. Yeah, looks pretty good. I got to do some work now. This is terrible. It's going to be 64 plus, well, I got to do that 3.7 squared now. And I'm not being able to make a mistake, by the way. I really mean that. So 3.7 squared. Let's see. 7 times 7 is 49. Let's see. 21, 25. 3 times 7 is 21. 9, 10, 11. 9, 6, 3, 1. So that's going to be 13.69. Well, I got to do 64 and 13.69. And that's going to give me 77.69. I made a mistake somewhere. And I'm glad I did, by the way. I'll tell you why I'm glad. Because a lot of students don't think, they think, why does this guy never make mistakes? I make mistakes a lot. I even say it, but I made a mistake somewhere. So how do you know you made a mistake? I'm not getting their number, which is 154.25. So maybe I did something wrong. So what I do, I'm going to recommend it to you too, is erase this stuff. It's nonsense. There must be an error somewhere. Now, did I get the midpoint right? I got that right at least, but I got this all wrong. Let's try again. And by the way, when you're doing homework, you don't get something, try again and keep trying. I would say give up after a while, but I'm the kind of person that really doesn't like giving up. Let's write the distance down again. I'll be more careful. I'm not really concerned about where my error was. I'm more concerned about why I made the error. So let's see what you get over there. And I think I see it right now. So it's minus 2.7 minus 5.3. I really think I made an error in the second term. 3.1 minus a minus 6.4 is plus 6.4. That was my mistake last time. Let's do this. And it's nice to have a key because you can always check yourself. Minus 2.7 minus 5.3 is going to be, let's see, minus 6, minus 7, minus 8. And what's this give me? 3.1 plus 6.4. It's actually easier for me to do too. That would be 9.5. Let me repeat this. I'm not beyond making a mistake. I make mistakes all the time. 64. Let me do the 9.5 squared, by the way. Let's see, 5 times 5 is 25. 5 times 9 is 45, 46, 47. Boy, 9 times 5 is 45. 9 times 9 is 81, 85. And D is 154.25. Kind of a nasty number, isn't it? But I am getting that. And I'm seeing that right over here. I also want to point out, I used a calculator to get the square root of that, 12.42 to the nearest 100th. Again, I know I say it a lot to you. If you can't use the calculator, please come by during office hours and we can help you. When I say we, anyone at Essex, certainly in the math department, in the tutoring center, can help you learn to use your calculator. Thank you so much.